Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about B plus tree index files and how can we update on the insert and deletion on B plus tree index files and what are the complexities of the updation on this type of files. Now let us start with an insertion as an updation to the index files. As the index files can have two types of updation, insertion and deletion. So either of this insertion and deletion needed to split up the leaf nodes or the split up any nodes. Splitting up means that if there are already the number of nodes that we can attach with each of the values, then if one value more is going to come as an insertion, and if there is only one provision left for that field or the node, then we cannot have attached that value with the node. We need to split up the node and make in the arrangement in this way so that all the leaf nodes belong to the same order. Also the insertion is possible. So now say in our table, say in this one that we have got Mozart, Elvis Gold, Bill Kelly Creek, Elvis Emily, Gold Cat Skim, Mozart Singh, Srini Wu as the leaf nodes. Now Adams needed to be added up here in this group of Bill, Kelly and Creek. But if it is considered as an n equals to 4 pointers, that means we can have at most 4 pointers. We cannot just add it here. Otherwise, we cannot add any other Adams node here because it will disbalance our tree. As we know, B plus tree is the final consortium, it will be an balanced tree. So how can we do that? We first need to get attached with the Adam, Bill, Kelly and Creek and then divide it into two parts, Adam, Bill, Kelly and Creek, or Adam, Bill, Kelly and Creek. But in this way also we need to change the root node and the internal nodes. So now the middle of the node, if Adams is getting up to it, so Kelly will be given here, that it will be go to the next internal node, that is the preceding node to it. So if we move Kelly here, then we will have Kelly, Elvis and Gold, and then we can have the rest of this insertion just normal to the previous one. So we just need to make this change, that we need to make Kelly here and otherwise it will be same. So what it will look like? I will just draw that Elvis, Kelly and Gold and how it will be converted into a B plus tree on insertion to the Adams. Now see, if Elvis, Kelly and Gold belongs to the internal node, it does not happen and affect the internal node at all because the internal node can support more than 3 pointers, that is maximum 4 pointers. So we can accommodate 3 values easily. And there is no need to update and upgrade that splitting up into the Mozart. So we are just having the Elvis, Kelly and Gold as an internal node. So now my left side of Elvis will get this Adams and Bill. Now in the left side of the Kelly, we will have Adams and Bill. Now to the right side of the Kelly and left side of the Elvis, we will have the Creek. Now, is this the leaf node? The Kelly need to be repeated here. Now at the right side of the Elvis, it will get the Elvis and the Emily. Finally, to the right side of the Gold, it will have Gold, Cats and Kim. And on this left side of the Srini, it will have Mozart and Singh. And finally, to the right side, it will have Srini and Wu. So in this way, Adams is getting added up to our existing B plus tree, and see that we have to split up this Kelly, Elvis, Gold to Adam, Bill, Kelly, Creek, Elvis, Emily, Gold, Cat, Scheme. So the 3 nodes are now become 4 leaf nodes, and we need to upgrade this Kelly here or the Elvis and Gold because that Adam we needed to upgrade it and add it to this one. Now this becomes more complex if it is upgraded node need to have it make it to the root node. Now let us see another example. Now if I want to add to this existing B plus tree another more updated value, that is lamp. So how can we add lamp to this one? So the lamp will be the right side of the Gold, which has called the Gold, Cat, Skim and also lamp, and it will be the red side of the Srini. And as the Mozart will have it the left side because JKLM, L belongs previously to M. So now gold, cats and Kim and lamp cannot be accommodated in a single one. So it will be like if we move this gold one and this previous that it is already in here. So we have to move this cat, scheme and lamp. In this way, though the gold needed to be here in the root node because we are splitting up an internal node which will have the Kelly, Elvis and cats as is the right part. So how can we do that? We will now improve the B plus tree in this way. So can we have this B plus on the Mozart, Elvis, gold and this cat, scheme and lamp as a subtree. So let us this say one. Now if we move like this one, then gold need to be upgraded here so that we can have as the part of the right gold this Kim, cats, lamp and also gold because it will be the riff node. So how can we do that? We have to either add an internal node but it will disbalance the tree. Other than we can add this gold to this root node because the root node has got two empty spaces for the values. So we can easily add this gold to the root node. So not only the leaf nodes, we can add also the nodes to the internal node as to the root node until and unless we are having an issue with an pointer to that particular node. Now, if there is a problem in the root node too, then we can have this splitting out of the root node and then have these two parts as the internal node. But the main and one condition is that the tree is needed to be a balanced tree. So now we will have this Mozart included and the lamp added up to this field that we are having in this B plus tree index files. So now on the left side of gold, we are having Kelly and Elvis. And on the right side of the gold, we will have Kim. Because in the internal nodes, we do not need to repeat the nodes until and unless we are finding the leaf nodes. And on the right side of the Mozart, we will have as usual Srini. Now on the left side of Kelly, we will have Adams and Bill. On the right side of the Kelly, we will have this Emily and this Bill and Elvis. But it is at the leaf node, so we need to include Kelly also and the right Greek. Now on the right side of Elvis, we will have Elvis and Emily. Now on the left side of the Kim, we will have the left out on this gold value, that is the cats. As gold belongs to the Kim, so the Kim's left side have to contain gold as a part. So the gold and cats will be left side of the Kim. Right side of the Kim will contain Kim and lamp that is being added to. Now the left side of Srini will have this Mozart and sing. Finally, the right side of Srini will have Srini and Vo. And all the left nodes will be connected with each other. Now this is the insertion in an B plus tree. Now we need to code it in an SQL that how to insert an item into a B plus tree. Now for this insertion, we will have the following convention. We will have the T, the L and P. For that, L is containing a value for which P is pointing to. That is, if there is a common pair L, Ki, then L is the value of the record of the values which has got the search key Ki and Pi is the pair for the rest of records and Pi is pointing to Ki. Same with the T, just with a temporary one. Now we will see that how to insert in an SQL query on a B plus tree index file. As we know, for the insertion, we will need a procedure because it will not return any value, and we will insert the value K within a pointer P that it will point to. Now the first case that we will solve, that tree is empty. That means we are inserting the first node to the tree. So we will create a tree with the root node L and with value K. And now it will point to null because it is the first node. Now we will have the leaf node L which contain the value K. Now that we have found that the value K within this leaf node L, next we will perform our next part. Now suppose n is the number of pointers that can be allocated in a node and L has got n-1 key values. That means if n is the pointer 4, then we can accommodate number 3 nodes to a particular node. So the three values, if there is already 3, then we cannot insert it. And if there is less than 3, then we can just insert the value v to the leaf node L. Other than, we need a split up. Now we will use the insert in leaf function, which we will define later with this L node, the K value and the P pointer. And if it is not that 3 numbers of pointers are already there, that means all the values are filled up with the leaf node, then we need to split up the node. Now we will first create another node L dash with the value that is want to be add up. Now we will have to join this node into our existing B plus tree in such a manner that the splitted up node, that means at which point it is splitted up, we need to put the value to the internal node. That means its preceding node. Now first we need to copy all the values to a temporary variable t so that we can use the splitted up from this t, because now we will insert L dash in L and we will lose the previous values. So we just store it in this t temporary variable. Now in the leaf node, we will insert the temporary variable k and p. Now the t has got less than n minus 1 values as we have splitted it up with the previous k n minus 1 values. And now we will add the k and p to the existing node t. Now this is a very important part here. We need to look that L dash Pn combination should contain all the pointer to the LPn. That means the last one with the previous node will be the first one pointing to the next leaf node. And also the last node in the previous one now point to the next child node. So we made that the splitted up node that was pointing to the internal node in the first part, and next the L dash will be pointed up by the part that is being splitted up to the internal node, and the right one will point to the new child node. So it has been an arrow condition that we have already seen that Adam and Bill in a part of the left to Kelly, and Kelly and Crick as a right part to Kelly. So Kelly is included in the leaf node Kelly, Crick, because it is the leaf node we need to include all the values from our files. Now that we have splitted up the node and make it within temporary T node, then we need to remove this L.P1 because it is the first node and now it is being the part of the internal node or the middle one, or can be the left one, but it has been part of the left node to the internal one. So we need to remove from this L kn minus 1 and from L. So through L kn minus 1 means the combination of the pair L and kn minus 1, that is the last value to the first value, was removed from this L. Now we should copy all the values from T pointing to P1 to half of the pointing to Q2. Why half? Because half of the part like Adam and Bill will be the left node, Kelly will be given up to the upgraded internal node, and Kelly and Crick as the right node. So we need to copy this TP1 to the half into the L, and after that, from that L, we should start the LP1. That means Kelly will be started into the next leaf node. Now the all right parts will be given to the right leaf node. That means Kelly and Crick will be the right leaf node because n by 2, that means Kelly and Crick, which was the last part. Remember that Bill, Kelly and Crick was the leaf node. We have made Kelly into the upgraded node. Make this n by 2 that Adam and Bill and Crick. So Adam and Bill be the left node with this one. That is, we are copying to the P1 through the half of the node starting at LP1. That means the first pointer of this first left leaf node. And then we are copying the rest of the nodes, that is till the Kn from L-P1. That means Kelly will be copied to the next leaf node and this is the right one and added to Crick it. Now we can see that we are finding K dash in such a way that is the lowest value in L dash. What is the lowest value in L dash? That is Kelly here. So Kelly will be the first in the parent node. So we are inserting Kelly in the parent node with the left one as the left child node with the L dash at the right child node. Now this is for an insertion into a normal procedure. Now there are two procedures that we have introduced in this one, insert in leaf and insert in parent. Insert in leaf is very easy, just insert the root node into the leaf one, and the parent is the splitted up part that has been this one. Now we need to check that it is the left one, the middle one, or the right one for n equals to 4. Now insert in leaf has got the node value L, the value K, and pointer P. Now if the value that needed to be add up is less than the value on the first pointer to the left child node on the left leaf node, then we need to again have it in the left part and then shift the P1 to the right part. And now if it is K greater than the value LK1, then we need to put all the values from the K1 until the value that has been less than K, and then after put K and after the rest of the values. So if Ki is the highest in L, that is less than K, then we need to insert that before K. So that is the part of this inserting leaf. Now how to go for the inserting parent? That means the leaf node has been split it up and we need to get the middle value and put it into the parent node. Here we have two nodes as the left child node and the right child node, and the value as the middle one. Now if n is the root, that the which of the parent node, then root node be the parent node, then we need to check and add it to split up the trees on the children node as the leaf node. Now we have to create that R as the root and create a node first R with this n as the left internal node, K dash as the value, and n dash as the right internal node. And after that we have to make R as the root. Now if it is not the root, that means it is a parent. So we are taking P as the parent of n. Now if P has got the values less than n pointers, then we need to perform the next. So if has got any space in this node, then we need to space it, insert it in P after the values of n, because P is the parent of n. And if it's got any n pointers that is filled up with the parent node, then we need to split it up again just like the insert node. Now we need to copy the entire content of P to a block of memory T, which can hold the P as well as the pair K dash comma n dash. Now in T after n, we need to insert this K dash n dash, which has got any space with this T. So now T becomes my new splitted up node. Now after erasing all contents from P, we will need to create a node P dash so that we can make this from T to the P dash as the new inserted node. Now half of this T that is starting from T1 that holds the value for P, that half of it will be stored to P, and we have erased it from the P, so the P will now have a new node having all the values to the middle one. Now from the middle value that is needed to be upgraded to the parent node, that we are splitting it up, we are taking it as this K double dash. Now rest of the values we will need to move into the P dash as the next parent node. Next we need to call it in a recursive way with this inserting parent, that the new value will be given to the next parent node, add the P on the left parent node, and P dash is the right parent node. If that one that we are adding up as the parent also has got no space, then again it will be splitted up. It will be splitted up like this one, moving to the root. Now let us move to our next part, that is deletion from a tree. Now say I want to delete a field that is Srini from this one. So how can we delete it? If we delete Srini, then this entire node will be deleted. So we cannot just do this after being splitting up. Now it will be marching up. So where the T is of the deletion, we need to march up in this way, that the marched up field should contain all the values limited to the number of pointers. And if the marched up values is not held by all the pointers, then we again have to split up the marched up values. But first we need to march it up. So how can we delete Srini from here? If we delete Srini, then we will have this Mozart, Singh and Wu left in the right side of this Mozart. But we cannot just have it, because the Mozart, Singh and Wu is the right part. Then we will have an imbalanced tree, as there is an internal node of Kelly Elvis called Adam, Bill, Kelly, Creek and Elvis Emily as the leaf node. So there will be a degree 2 and degree 1 imbalance of the left and right of the B plus tree. So to balance it, we need to move the Mozart to the right part so that we can have someone from Kelly, Elvis and Gold to the root node. Now if we make this one as the root node, again we will have the leaf node and this right node, degree 1 and degree 2 imbalance. So this Kelly, Elvis and Gold, if we move this Elvis, then again the problem stays. If we move this gold, only that way the problem can be solved. Now let us delete Srini and see how can we combine the values together so that we can get a balanced b plus 3. So from our last example, we have seen that we need to move gold to the root of the tree so that we can have Kelly and Elvis and the left child and the Mozart as the right child. Now the Kelly will have the left as the Adam Bill, right as the Kelly Creek, and Elvis at the right as the Elvis Emily. Now the left side of the Mozart will have the gold as the previous value of the root node as the leaf node, and Cats and Kim followed by as the left node. Finally, with the right side of the Mozart, we will have Mozart, Sing and Woo. So now all are my leaf nodes will have the parent node and Mozart and Kelly Elvis. So now the leaf nodes will be connected to each other. So we can have a successful deletion on having the final updation. So what are the things that we have emerged from here? That gold is being placed where the Cats and Kim with one value left right there. And if we delete the Srini, then there will be a disbalance. If we make the Elvis gold as the root, there will be also a disbalance on the left side. Kelly and Elvis cannot make because that will also make an imbalance. So we just put gold here, Kelly Elvis on the left side and Mozart on the right side. Now we will see that how we can use an SQL query for this deletion on this b plus tree. So if the deletion is in the left node, then there is no hurry that we can choose the left node deleted from there just exactly like this leaf node deletion. Because the leaf node has got already the values, and if it is in the balanced one, because it is in the leaf node, so we can just delete the values from the leaf node. So we just need to perform the function delete entry to delete this k, p from the node L, that is a leaf node. Now we will define the delete entry. Now we need to delete the kp from n. Now if n is the root node, that means n is the final node that our tree is having, so we can just delete it and make the parent node as the root node. So if we send the root and being one of the child is the node and is the only one child as it's a parent node of the root node. Now we will make the child as the new node because it is the only child node, and then delete the root node n. Now if n is the root node but it has got many more values, not the one, then let this n dash be the previous or next child of the parent of n. So make this n dash as the previous or left child. That means the left child or the right child of n. Now k dash with the values between the n starting from until the ending of this n dash. Now if the entries of both the n and n dash fits in one node, that means we are merging it up. We just need to merge up. Now if it is n the predecessor of n dash, that means the child node being the predecessor of the parent on this n, then we need to swap the values of n and n dash, because now the left one will have the lowest values and the right one will have the largest values, because n is being the parent of this n dash. Now if n is not a leaf, that we have split it up and it has not a leaf, that means it is also a parent of another leaf node. Now all the values to k dash, that has been the deleted value, and after that we have calculated the middle one, we should put it into the new n dash. Other than that, if it is not the single value, then we need to pair all this k value and the pointer pi to this value from this m to the n dash. Now the child pointer will be the pointer of this parent because we have moved the value from the child to the parent. Now we need to delete the entry for this k dash, which has the parent of n as the left child and the n dash as the right child. Now if n is not the predecessor, that means it is the successor, that is belong to the right part of n dash. Now if it is the successor, then let m in such a way that the combination of the last successor, that means the last part or the value of the successor, that the m pointer is pointing to, that is p, and the value is k and belonging to the node n dash, and we are taking the value as m now. Now we need to delete the value or move it from this n dash and then put it into the new of this node. Now we will make this n-pm and n-km, that is the pointer and this value to the last one, as the first pointer by shifting all other to the right, because it is the least value that we got from this n-. Now we need to replace the k dash that we have made as the middle value in the parent n by this n-km, that is the km value of this n- field. Now, if it is not the root node, then we just to delete it, just like this one that we have followed for the predecessor and successor of n. Now we need to follow that for the n-. Now in this way, we can delete the value of a B plus tree index files using the SQL. Now let us move to the context of an unifier attribute. Unifier attribute is an extra attribute so that we can get every value is unique. Because if the non-unique values are there, that means a search key can contain and points up to 2 or more records in an index file. So that will end up that from deletion, which value it be deleted. Or if the search key is deleted, then what the value it will be pointed to on this parent node. So we can put the unifier attribute to each of the values in this index files so that we can get one search key that is being pointed to every of this result. Say for our instructor relation, which got the salaries. If we made this B plus tree on salaries, then it can possible the salary 60,000 belongs to many of these pointers and it will be pointed to many of the information. So how this will be wrapped up? It will be creating a problem. So we need to put an unifier address, that is the attribute will be given some of the condition so that they can achieve it while giving the unique constraint. Now what happens that if we compare these complexities of the B plus tree updation, we can have the log n by 2 at most number of complexities in the worst and this best case scenario of this updation in the B plus tree, either in the insertion as in the deletion. As we see there are no number of pointers, then it is less complex to insert and delete because we can easily add up or delete from these data. And if it is more complex, then we have the less number of pointers to it. Need to split it up again and again and again so that we can have a balanced tree. So that is all for this updation of a balanced tree on a B plus tree index files. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.